Next problem is 11th one. Cos A plus sin A whole square plus cos A minus sin A whole square. Here A plus B whole square formula and here A minus B whole square formula we have to apply, and finally we have to prove 2. We should assume LHS. Cos A plus sin A whole square plus cos A minus sin A whole square. First formula, A plus B whole square formula. Cos square A plus sin square A plus 2 into cos A into sin A. A square plus B square plus 2AB. Okay. Next, A minus B whole square formula. Cos square A plus sin square A minus 2 cos A into sin A. Any cancellations are there? Minus 2 cos A sin A. Here plus 2 cos A sin A. Cancel. Here cos square A, cos square A. 2 times is there. And cos square A plus sin square A formula 1. Next, here cos square A plus sin square A. Use identity. Here this bracket value is 1 and second bracket value is 1. Total 2. LHS is equal to RHS. Hence proved. Next problem is 12th one. Cosecant A minus sin A, secant A minus cos A, tan A plus cot A. Final answer is 1 we have to prove. So this type of problem, whatever possibilities are there, that and all we have to write. Suppose here cosecant A in terms of sin or cos, that we have to write. LHS cosecant A minus sin A, secant A minus cos A, tan A plus cot A. Cosecant A in terms of sin, 1 by sin A minus sin A we have. Here secant A we have to write in terms of cos minus cos A. Tan in terms of sin and cos, sin A by cos A plus cos A by sin A. Here first bracket LCM sin A. Here 1 minus sin square A. Next, here LCM is cos A. 1 minus cos square A. Next bracket LCM is cos A into sin A. Cross multiplication, sin square A plus cos square A. You should observe first bracket, 1 minus sin square value is cos square A. We can use identity. Cos square A by sin A into 1 minus cos square A plus, we should write sin square A by cos A into, here sin square A plus cos square value is 1. Cos A into sin A. Any cancellations we have to do cancel. Here, here cos into cos. 1 cos, 1 cos, 1 more cos and here cos. Here sin, 1 sin and sin we have to do cancel. We have to prove 1. All cancel. So 1 it will come. RHS. LHS equal to RHS. Next problem is 13th one. Here 1 by secant A plus tan A equal to secant A minus tan square A. LHS, RHS both we have secant and tan. So I will consider LHS 1 by secant A plus tan A. Next problem is 13th one. 1 by secant A plus tan A equal to secant A minus tan A. Both LHS and RHS we have secant A and tan A. I will consider LHS. Secant A in terms of sin and cos only we have to write 1 by cos, because secant cos reciprocals, plus tan A formula sin A by cos A. Denominator we have to take LCM. Cos A is the LCM. 1 plus sin A. Reciprocal you should write. Cos A by 1 plus sin A. This type of problem we have to do denominator rationalizing. Denominator rationalizing means here plus means minus we have to multiply and divide. 1 minus sin A by 1 minus sin A. Numerator you should multiply cos A into 1 minus sin A. 1 minus sin A. Here denominator A plus B, A minus B formula we have to apply. A plus B into A minus B, A square minus B square formula. Here cos A of 1 minus sin A divided by, here 1 square, value is 1 minus sin A whole square, sin square A. Numerator as it is, you should write cos A of 1 minus sin A. Denominator you should observe 1 minus sin square A. Value is cos square A. We can use identity. Here 1 cos A, here 1 cos A cancel. Remaining 1 minus sin A by cos A. But our answer is in terms of secant tan. Here we have to split denominator. 1 by cos A minus sin A by cos A. 1 by cos A, formula is secant A. Minus sin A by cos A, tan A. This is our RHS. RHS. Therefore, LHS equal to RHS. Next problem is 14th one. Sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. Here LHS we have to take and RHS we have to prove. Here you should observe what formulas we can apply here. A plus B whole square and A plus B whole square. Same formula we have to apply. Sin square A square plus B square plus 2AB formula. Sin square A plus cosecant square A plus 2 sin A into cosecant A. First bracket value. Next second bracket value. Cos square A plus secant square A plus 2 cos A into secant A. Here sin square A plus cos square A. I will write in one bracket. Sin square A plus cos square A. Because we have one formula. Next, plus here cosecant square A plus secant square A. This is one bracket plus here 2 into sin A into cosecant A. How to write? 1 by sin A plus here 2 into cos A into secant A. 1 by cos we can write because cos and secants are reciprocal. Sin A cancel. Cos A cancel. Here sin square A plus cos square value is 1 plus here cosecant square A. Our answer is tan cot only. Cosecant square A formula. Identity we can use. Cot square A. 1 plus cot square A is equal to secant square A. 1 plus tan square is equal to cosecant square A. These two formulas you should apply here. See cosecant square A plus 1 plus tan square A. 1 plus tan square A plus secant square A plus 1 plus cot square A plus here 2 plus 2. 2 plus 2. Now we should add 1 plus 1, 2, 2 plus 1, 3, 3 plus 4, 7, plus tan square A plus cot square A. Our proof is proved, RHS. Therefore, LHS is equal to RHS. Next problem is 15th one. Secant square A into cosecant square A equal to tan square A plus cot square A plus 2. So, right hand side tan cot we have. Left hand side secant to cosecant we have to write in terms of tan and cot. We have identities. What identities are there? 1 plus cot square A is equal to secant square A. 1 plus tan square A is equal to cosecant square A. These two formulas we can use. Here LHS. Secant square A into cosecant square A is equal to secant square A. We can write 1 plus cot square A. Cosecant square A plus 1 plus tan square A. These two brackets we have to multiply. 1 plus 1 into tan square A. Tan square A plus cot square A into 1. Cot square A plus cot square A into tan square A. Cot square A into tan square A. 1 plus, here tan square A, cot square A. As it is, we have to write plus cot square A plus, here cot square A, cot A and tan A are reciprocals. Either one we have to change. Cot square A we have to write tan square A into tan square A. Both cancel. 1 plus tan square A plus cot square A plus, here both cancelled. Remaining 1. 1 plus 1, 2 plus tan square A plus cot square A. Therefore, RHS. LHS is equal to RHS. And